All right. So one of the questions here is number 5 on homework 1C. And so it's got 3 different graphs. I figured we'd do the and remember that your numbers might be slightly different. So this is homework 1D, 1E, number 5, graph C. All right, so this question is asking you to create. So first of all, this question, let's say sequence. Right, so that's a common question, common issue that students are having is because some of the questions are asking for what is the total weight, some's asking for the circuit. So the first question here is I'm asking for the nearest neighbor algorithm. My pen here, right? Henceforth, NNA starting at B. All right, so I want to go ahead and mention this. First off, if this is complete with a vertex. With 4 vertices. So if I'm starting at B, what's going to happen is just like with the valences, I'm going to have 4 different choices from my beginning point. So starting with B, I'm going to have 4 choices. And then my next one, then we'll be down to 3, down to 2 choices. And then after that point, I'm kind of forced to finish. All right. So I'm going to highlight my choices as I go along. So starting with B, my 4 numbers are from B to A, which is 99.
Excuse me.
Yes, ma'am.
I can't see your screen.
I'm so sorry. Thank you. All right. I thought I was sharing and it was not sharing. All right. So let me just recap everything I just mentioned. So we are doing homework 1D, 1E, graph number 5, or number 5, graph C. And then just as a reminder, this is asking for a Hamiltonian circuit and not an aggregate weight. So your answer should be letters instead of numbers, right? So my graph here has numbers. Yours might be different, but just be on the lookout for that. So starting, this is not 4 vertices. This is 5 vertices. Right, we have a complete graph with 5 vertices. A complete graph means that you can get from any vertex to another vertex in one step. So if I start with B, what's going to happen is it's always going to be decreasing in number of choices. Right, we'll start with 4 choices, A, C, E, and D. And then as we go along, as we visit vertices, we're going to narrow down our choices because once we start visiting things, we're going to have fewer things left over to visit. So starting with B, my choices are these numbers from B to A. We have 99. B to C, all right, if you look at this segment here is an 84. B to E is 88. And then B to D is 112. So that's going to be my choice here is C, right? That 84 is the lowest value I'm going to have. So once we go there, right? So I'm going to go ahead and highlight what I've visited, right? Once we go to C, we now have 3 choices remaining, right? We can either go C to A. We don't want to go C to B because we've already visited B. C to D would be this 121, then C to E would be this 96. So that means that we're going to choose the 96. So we're going to go to E here. All right, and then so from there we have 2 choices remaining, right? Again, as we go along, we narrow down our choices. We have 2 choices remaining. This time we can either go to E to D, or E to A. So E to A is this number right here, right? So we're going to choose that 93. So we're going to go to A, and then that narrows down my choice. We have 1 vertex remaining. All right, so from A, we're going to go to D here. And then always at the end, we're going to go back to our final vertex, our original vertex, which is going to give me that 112. Right. So you should always be comparing 4, 3, 2, or just decreasing in number by 1. Right. So there's going to be my answer here. So the question is just asking for the circuit B, C, E, A, B. So that would be the nearest neighbor algorithm for this problem. All right. I'm going to grab the graph again, and then we're going to talk about the sorted edges algorithm. And so, as I mentioned in class, what I'm going to do for sorted edges, if I were to put that on the test, is actually go ahead and put everything in increasing order so that you don't mess up because you accidentally have them out of order. And I want to make sure that you know the procedure and not be hung up on that step. Because if you have that first step wrong, the rest of it is going to be wrong. It's going to be hard to get the problem right. So here we go. So you can just check behind me. Zoom. All right, so the lowest number is a 78, which corresponds with AD. Then we've got an 84. And then we've got an 88. 88 is BE. I think 93 is the next one. 93 is AE. And then 99 or 96. And then AB is a 99. All right, let me cross those off. 78, 84, 88, 93, 86, 99. 103 is the next one, AC. All right, 112, BD, 121, and then 130. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that gives me the 10 vertices. All right. So remember, for the sorted edges algorithm, we're going to have the procedure here. First off, the first is that put them in order. So that's done. Next thing is we always use the 2 shortest. So we're going to use AD and BC. I'm going to go ahead and highlight those. And again, this is not drawn to scale here. AD and then BC have the lowest weight, even though they might look like one of the longest segments here, right? And then remember the main step here, the 3 things, is that no tripoints, and no early circuits. Usually what's going to happen is you're going to end up making a triangle, right? So if I were to try to put BE, BE would be okay, right? If I were to do this, there are no tripoints, there's no early circuits. So those first 3 are okay. Right, the next one is AE, which again is also okay. There's no early circuits. You can kind of see that we're almost finished, but let me just finish the procedure here, right? If I were to do CE, CE is going to give me a tripoint at E here. So this is what I mean by a tripoint. If I were to highlight that, there's going to be 3 different edges, 1, 2, 3, that converges to E. So this is what I mean by a tripoint. Right, so that would be not allowed here. So I'm going to erase that because we don't want that to happen. Oh, come on. Okay, the next one is AB, which is this one right here. So same thing, right? We're going to create tripoints at 2 different places. So that's definitely a no. Right. You can kind of see already that we need to finish this off by using DE, DC. But I'm just going to go with the procedures here. Come on, that's not what I wanted to do. Erase this, 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 right? AC will again give me that tri-point, right? Tri-point at A, so that's a no-go. Right, again, that would have 1, 2, 3 things going towards A, which is not something we want. All right, and then one more time, BD. If I were to try to highlight this, it's going to have a tri-point at B. So we don't want to use that one. And then finally, CD finishes off my star here, right? That one finishes my circuits. That one is okay. So that would give me the answer here. All right, so let's finally answer the question here. So the sorted edges algorithm tells you which edges to use, but doesn't tell you what the circuit is going to be. So you're gonna have to create that on your own. And you have lots of choices here, but it does tell you to start from point B. So from point B, I can just kind of follow the star here. We can go B to C, C to D. All right, so notice I'm not really following the increasing order anymore. I'm just creating my circuit. B to C, C to D, D to A, and then A to E, and then back to B. All right, so this would be one of the correct choices. Obviously, you can rotate it backwards. Right, you could go B, E, A, D, C, B, and that would also be a correct answer. So this is what the question is looking for, and this would be the procedure on how to